introduce Professor Vad Mathiesen. Professor Mathiesen holds a PhD in fuel cells and electrolyzers in future energy systems. His research focuses on technological and socioeconomic transitions to renewables, energy storage, large-scale renewable energy integration, and the design of 100% renewable energy systems. He's one of the leading researchers behind the concept of a smart energy system, electrofuels, and heat roadmap in Europe. He has published 250 scientific articles and reports, and is one of the Clarivate Web of Science list of highly cited researchers, those among the top 1% most cited researchers globally. In 2022, was the most cited researcher in Danish media across all topics. Among other positions, he has been part of the European Union Commission Expert Group on Electricity Interconnection Targets and the Science Advice for Policy by European Academies, Expert Group on a Systematic Approach for Energy Transition in Europe. He's a research coordinator of the Sustainable Energy Planning Research Group. He has been PI or Principal Investigator, Work Package Leader, and participant in more than 75 projects in Europe. In 2012, he founded the Master of Science program in Sustainable Cities at Aalborg University. Furthermore, he's in the editorial board of the Journal of Energy Storage, the Journal of Sustainable Development of Energy, Water, and Environmental System, Associate Editor of Energy, Ecology, and Environment, Editor of the International Journal of Sustainable Energy Planning and Management, and he recently started the new Elsevier journal, Smart Energy. In addition, he's a member of the Danish Academy of Technical Science, the Advisory Board Think Tank Europe, a board member at the Danish Energy Technology Development and Demonstration Program, Radius Elnet, and Senior Fellow in the CIP Foundation. So it's my pleasure, and please welcome in joining Professor Mathiesen in the presentation titled The Geopolitical Challenge on the Way Towards European Smart Energy Systems.
Thank you. I have here, I guess. Can you hear me? Does the sound work? I have to put it up a little. Okay. You can hear me? I need the clicker. Do you have the clicker? Thank you for welcoming me here to the 5th Latin American Conference, SDEWES Conference. I'm very happy to be here. It's a great honor. It's my first time in Colombia, not my first time in South America, but I look forward to some nice speeches here the coming days. I was invited to make a talk about the European energy transition, where it's not only the technologies that are transiting, it's also the political debates. And I'm from a small country of Denmark, which is a small part of the much more vast area-wise kingdom of Denmark, which also includes Greenland. So the kingdom of Denmark is very, very large, and larger than Colombia. So it's just to put a bit of weight behind my words here, but also to make you understand that we are in probably the largest foreign policy crisis since the 1800. So it's very, very tough, and you can see that the changes are not only technological, the changes are also in the political debates, which means now we're talking more about geopolitics than climate politics. So maybe we can talk a little about this since it's so topical right now. I flew in last week and I took this nice picture, and it kind of alludes to also what Nevin said earlier. This is a piece of democratic infrastructure that is going to disrupt most of the developed world, whether legitimate or corrupt suppliers of electricity, poor people, middle classes, everybody will want to have a PV on the roof if they can. And you can go actually also to Google Maps and you can see this in a lot of places. So it is also happening here, and probably this will accelerate in the coming years, but there are some local researchers here who of course know much more about this than I do. As you know, in Europe we have used energy for a long time. The the European Union in its current form was made up in the 90s, and I would say energy policy in the European Union started in the end of the 90s with the common electricity market. And after that, there has been gradual build-ons to what we do in common between the 27 countries in the European Union and what the individual countries do. But it is the responsibility of each individual country to do their energy policies. It is not the jurisdiction of the European Union to do that. Having said that, there are many collaborations between the countries. We have had quite a lot of success in some of the elements. So what you see on this graph up here is the increase in the amount of renewables since 1990. So this is really something that increases the security of supply, but at the same time, all of the other elements have gone down. The domestic internal EU production of coal and oil and natural gas has declined for a very, very long time. And at the same time that we have higher renewables, we have also increased the energy efficiency. And I'll come a little back to this. We have had no improvements really of our security of supply, because even if we have a higher efficiency and we have more renewables, we have so much less fossil fuels that our security of supply is around the same level as it was 20, 30 years ago. It has not really improved structurally because we're still so dependent on natural gas and oil particularly. The Juncker Commission in 2015 said they wanted to diversify the gas supply for Europe. That failed miserably, as I think it's clear for everybody. So there's really a lot to say about what happened before the invasion of Ukraine on the 24th of February 2022. The dependency was particularly large on natural gas, and the thing is, when you can transport something and you can pipe something, it can become very, very cheap. If you have a source and you can simply put it in a pipe to Central Europe, it becomes really a cheap commodity, which is a lot of interest in having, also knowing that you have to produce something. You can see here the oil and gas lines going across the eastern plains of the European continent, and they are all sort of from the north part of Russia. I don't know if any of you remember what happened in the summer of 2022. It's not actually on the map. There's a line here, not on the map. I'm not going to ask questions because the format is not for it. But there's a line in the Baltic Sea here that actually goes up here from near St. Petersburg and down to the German coast, and it's called Nord Stream. Nord Stream 1 was opened in around 2011, and then they decided to build Nord Stream 2. And what happened was that in December 2021, so before the invasion, this was actually completely ready. But at that time, the German Chancellor, Olaf Scholz, he actually chose administratively not to approve it because he wanted it to be this separate companies that were operating it. And this also was done in January 2022. So Nord Stream 2 was never opened. Nord Stream 1 was operating, Nord Stream 2 was never opened. And then in the summer of 2022, it was bombed, or there was an incident, or there was an event, or there was a terror attack, depending on how you view the world. In any case, it's not able to operate, And I would just like to remind everybody that all of those lines that are going with natural gas through Europe, they could have actually been abolished with the startup of Nord Stream 2, which would have completely changed the geopolitical dynamics in Europe and the collaboration within the European Union, because the interest would have changed completely and all the agreements could have been made by the anytime sitting Chancellor of Germany and the dictator in Putin in Russia. So this is just to say it is very, very political when you are so dependent on a single source. And actually we're really dependent on oil and coal as well. In February 2022, something else actually happened, because as the invasion started, everybody seemed to forget a little about COVID. But what had happened during COVID was that the European Union had really started to work tightly together with vaccines and measures against contamination of people. And this sort of very tight working together and fast working together was really convenient, because in May 2022, the Commission could set out a policy and initiatives called Repower EU, which is a response to our dependency on Russian natural gas. We were 45% of the natural gas in Europe came from Russia. So that was really a lot. So Repower EU had 3 policies: energy efficiency, electrification, fuel switch, so going even from natural gas to oil or coal if needed, but of course mainly other sources, and then the last one, deployment of renewables. And it has been actually a rather huge success. There's a structural sort of decline of 20% in the natural gas consumption over a very short time period. But when you look into the numbers, there are maybe some challenges here still. So if you want to understand the natural gas consumption in Europe, it has 3 parts. So one part is the electricity grid. A second part is for lukewarm water for heating houses. And the third one is industry. So that's around 1/3 to each. And when we see a 20% fall, structural fall, that is mainly due to the deployment of renewables. So this is a huge decrease of natural gas consumption in the power sector from deployment of photovoltaics and deployment of wind power. Then there's also a slight decrease in heavy industry, so ammonia has been moved a little out and there's a slight decrease there, but we have had very little success in changing our heating system, very little success in general in electrifying industry and getting rid of natural gas there. So there's still really a lot to do. Up here, you see the up here you see imports of natural gas to Europe, and you can see the bottom one, the red one, is Russia. Some of the countries close to Russia had 100% consumption of Russian natural gas. Some in the western part of Europe had very little, of course. So this is a European picture, but you could see the dependency was very high. We get a lot of gas from Norway that was increased slightly. Then we get some from northern Africa, so for example Algeria. But then after this invasion and to handle the crisis, a part of the Repower EU initiative was to expand our capacity to import liquefied natural gas. And this is where you see, for example, US liquefied natural gas is playing a larger and larger part here. And right now we get around 1/3 of our imported gas, a little more than maybe 40% of our imported gas from the international liquefied natural gas market. So of course that is a challenge. Just to highlight that Repower EU has been a success again, you will see a small you can see a small dip here from the fourth quarter of 24 to the first quarter of 25. And that dip is the stop of the gas going through the war zone in Ukraine. Maybe some of you know there was an agreement, especially for some of the Central European countries, to actually have natural gas through Ukraine. Ukraine did not want to renew it. We didn't really want to renew it, but that nobody really heard about it. Also in Europe is a big success. That you can close a big line like that for a part of Europe where there should be protesters. That is quite amazing. Of course, there were a few noises, but it didn't create a big media disaster or anything like that. So I think that tells us that it has been a rather big success. When we then look a little ahead, maybe we have to just understand a little more about what is actually going on here. Now, everybody in Europe would know what this is. This is the content of natural gas storage in our storages. So what will happen is we use a lot of heat and we use a lot of natural gas in heating. We could not import enough during the summer to heat our houses in the winter, so we would fill up our storages in the summer and then gradually use it in the winter. And that's where you see these sort of waves. And the big focus in the beginning of this crisis was, are we able to heat our houses and supply our industry? So this was a really, really big deal during 2022 and 2023. But we are in a very good place, actually. And up, so down here you can see the orange line. There's still quite a significant amount of storage of natural gas in so this goes to the first week of this year. Up here you see the consumption per month of natural gas, and here you can see the orange line, and you can see it's rather low compared to all of the other lines. So we're in a good place. Up here, I can see maybe it's a little hard to see, but up here is a graph of where we get the liquefied natural gas from, and it suffices maybe to say that the light blue one is the United States, and it has increased quite a lot. And then you have the red part, which is Russian natural gas. And the Russian natural gas goes to the international market for liquefied natural gas, maybe through India, maybe through some other countries. It's a little hard to know exactly what goes on. There will be a complete stop for natural gas. Also, hopefully from the liquefied one, it may be a little hard to control, but there are really huge initiatives so that this will end in the end of this year. But we have a big challenge. We have had progress with Repower EU. The Fit for 55 is the target to have reductions of 55% in the greenhouse gas emissions by 2030. And there has been a lot of successes here, but we're still 60% dependent on imports, mainly natural gas and oil. And we are very, very dependent on liquefied natural gas. And I made this slide before what happened after New Year about Greenland, and actually I made it this wording here, I made that in 2023. So, but I think it really holds true that we are very much subject to what happens in the world about tariffs or trade wars, and I think we're in a really risky situation. So this is a problem. If one good thing should happen out of this is to bring back attention on this problem. Because on the top one here, you see the natural gas prices. And you know what happens with the natural gas prices having this sort of structure? You can see the big peak. That is, of course, in 2022 and during the crisis, and also part of 2023. You can also see it falls, and it's not as low as it was before the crisis, but it relatively has fallen. And you know, people's attention span is about 3 months. And the politicians' attention span is also correlated to those 3 months, unfortunately. Which means that when we have seen the natural gas prices fall, the attention on this transformation is shifted. It's diluted, it's not enough, it's not there. Maybe if something good should happen out of this current situation with Greenland and the chaos in NATO, it could be that we get back on track with focusing on this. Of course, the Repower EU policies are still there, but even though the policies are still there, you need to screw on the nuts and bolts and do a quality check and make sure things are happening. The Commission has full speed on this. This is in the member countries a big problem. They don't have enough attention when the prices seem to be lower. What is for sure the case is that the prices will fluctuate in the future. They may be low sometimes, but they will also be high sometimes. So this is just a brief overview of where we get our products. So oil, more than 90% imported, a lot from Norway and the US, otherwise Kazakhstan, Nigeria, Saudi Arabia. Natural gas, 85% imported. Coal, 100% imported. As Nevin said, it's very little though, so it's not that big a problem. Uranium, imported. So those who correlate nuclear power with good geopolitical situation, I'm not sure they have read the textbooks. Of course, this can change, but it's not easy to change. And then you have renewable, which is primarily like domestic within Europe. So of course you can see that the challenges are really, really vast. So what we want to make sure is that we do things in the short term that help also the long term. So we need to have a really big strategic focus on this. I guess everybody heard about the Draghi report. Now the Draghi report is a comprehensive piece of work focusing on Europe's competitiveness and strategic autonomy. But the work in that report is not really something that is completely new. There's been initiatives on batteries and materials in the Commission since the late 2010s, at least middle 2010s. But this really highlighted it, and it put increased attention on it. And this combined then with this geopolitical situation, I think, makes everybody understand in Europe and stand more together in Europe about what we have to do. So right now, national and international security policy is on the top. So this is about geopolitics. It's about economic sovereignty. It means we have to actually have economic power to be able to sustain things. It's about the industrial policy. Then there's a security of supply element, which is also connected to this, cybersecurity. We have all of this debate about materials, sourcing, processing of materials and supply chains. These things the prices are falling a little again after the war started, so it's normalizing a little, but we still have challenges in this respect. And then you have everything else, those small challenges like biodiversity and climate change and health effects that some people, I guess, also care about. But luckily, I would say you have to understand that solving all of the other problems goes really well hand in hand with solving the problems with regards to climate change and other environmental issues. This is just an example of, you can go and have a look. There's a homepage, EU homepage, where you can go into each material and have a look about what is the status of this critical raw material. This graph over here shows where different materials for the transition are from, and the red part, I guess you can guess is China, which has a significant power, especially in the rare earth department, but also in quite a lot of other less critical materials. But as part of this response, the Critical Raw Materials Act was inaugurated, or was put through, and as part of this, there are some benchmarks that the EU is targeting, and this is being done actually with investments, with concrete investments. So 10% of EU's annual consumption has to be EU extraction. 40% should be processed in EU. We have to recycle more, and we cannot be more than 65 dependent on one country, which is, of course, quite a lot. But the year 2030 is also very, very close, I would say. Now we turn a little into sort of the renewables part, and I put this slide here on what is happening in Denmark. So we have now almost 60% wind power and probably around 10% PV in the electricity grid. So this is quite substantial amounts. It's really a lot, and I can tell you we don't have any blackouts or any problems with it. It's functioning very well. But of course, there's always debates about this. So right now, the debate in Denmark is a lot about, so how can we get even more up? And I would say this is a little silly. So if there's a politician that wants to be green in Denmark, they would like to put up more PV and wind power. But this is a little wrong. They have to focus on other things. In my opinion, we solved the renewables part more or less to the extent possible in the electricity sector, and we have to then have a growth of renewables as we grow the electricity consumption. So if we exchange a fossil fuel car with an electric car, and we do a lot of that, then we need a little more electricity, and that should be the growth rate. We don't need a 20% growth rate. We can't sustain it, and I'll come a little into why that is. But what's important to understand that Denmark is also a little of an outlier. I'll come into that in a minute, where I compare to some of the other EU countries. When we do the transition and when we want to have better competitiveness in the EU, of course it's important we choose the cheaper electricity production option, and this is from Lazard, from a levelized cost of electricity. And you can ask me afterwards maybe what are the system integration costs, and then you have to combine with batteries and whatever. So we can go a little into that. But you have to understand that if we have an energy system that is mainly based on electricity and not burning fossil fuels, the system integration part is so minute and small compared to the overall cost of the electricity production. So you want to focus on enabling a lot of the cheapest options on renewables. And now Neven already talked a little about it. PV, especially utility scale, are very, very cheap options in many parts of the world. In Europe, onshore wind is cheaper in many places compared to PV. And after that, we can also see we have offshore wind, which is down here. This is an American consultancy who makes this. So of course it reflects a little what's going on in America. So when you compare onshore wind here, 37 is the lower one, $37 per megawatt hour. PV around the same. Then it's almost twice when you look to offshore. That would not be the case in Europe. That price would maybe be 30% higher compared to offshore or something like this. So for sure you want to focus on the cheaper option. Down here you have then the different sort of power plant options: gas peaking, US nuclear, coal, combined cycle gas. And what we want to do is we want to try and enable a lot of these to come into the grid because they're cheaper option. Just to talk a little about nuclear, here you can see in most studies it's around 3 to 5 times more expensive to build nuclear compared to renewables. But this requires an operation time of 8,000 hours per year, so 75–80% if you can. So and this is not very well fit with renewables. So from a systems perspective, you have a choice. You either go for renewables or you go for nuclear. It is not so that we want to build nuclear to support the renewables, because if we support the renewables, then the operation time goes down, and you can times the cost, the capex of the nuclear with the lower amount of hours that you would use it. A lot of the time you hear nuclear is cheap. That's because it's apparently very hard to understand the marginal price market you have to have on an electricity system. But even in this study here in Lasat, they put a number here. So I don't know why they do it, but they have this number here, 34. This 34 is assuming that all of this is written off. So this would be the marginal price. But for me, it's a little strange to have this number here, because I'm missing the 0 on the wind and the 0 on the PV up here. So if we imagine some kind of imaginary bank that comes down from the moon and pays for the nuclear power plant and says, now you only have to pay $34 per megawatt hour, I would rather have they paid for 5 times the amount of renewables and said you have to pay 0 for that. So this creates a lot of trouble in my opinion to understand this. Yeah, this is just an example of in Europe we're looking a lot at the North Sea to build out offshore wind. There's really a high potential for onshore wind, but in certain parts of Europe, in Northern Europe, there is a need for so much energy. We also need to look into offshore, and there are studies about making these offshore energy hubs. Some call them energy islands, and these are offshore energy parks, maybe above 5 gigawatts. So it's rather large, really large production sites. Another thing about the electricity supply from these renewables is how different they are. Now, in this part of the world, PV, of course, can dominate the system. But as Nevin said, when you come up north, we need more supply of wind power as well. So if you have a PV in Europe, or at least in the northern part of Europe, then around 85% of the production will be within half a year in the summer and in the daytime. And there'll be very little production in the winter time. And we use more energy in the winter time. And here actually wind fits in very well. The wind is here, a production curve is blue. You can see it's slightly higher in the winter time. And when you design the system, it's really important to understand these elements, and we call it the capacity factor. So if you have 1 gigawatt of PV in Europe, maybe it's around 15% capacity factor or full load hour, however you prefer to call it, whereas the onshore wind would be between 25 and 40% depending on where you are in Europe. And this has a huge impact also on how you design your electricity grid. And when you have penetration rates of 65% renewables, this becomes very, very important. In Denmark, our peak demand right now is around 6 gigawatts. It's nothing compared to many other countries, but just 6 gigawatt. We have 5 gigawatts of installed solar PV. Do you think that those 6 gigawatts of peak demand occurs on a summer day? No, it does not. This creates a huge problem, of course, but it also creates a good situation because it means we have a lot of PV in those hours of the year where the sun is not shining so much, but where we still have this capacity. So it does help the system overall. It's just important from a design point of view. Yeah, it's a little hard maybe to see this, so I'll try to explain it. If we see the Danish system, it's often looked to as a sort of a role model as what you can do. But in effect, Denmark is a very, very small country surrounded by countries that have 4, 5 times, even 20 times the electricity demand than we do. Of course, we don't have full connection with these countries, but we have connections with the countries. If we had no connections, we would not have 65% wind and PV. We would have somewhere around 45-50%. That would be the maximum in the combination of wind and PV. So from a structural point of view, also when we lose a lot in the summer and all of this. This means that if you transfer the 65% to all of the European countries, you're doing a really bad mistake. So you can't take that as something that you can simply copy. You can do something, but that's changing the demand side. I'll come a little into that in a minute. This is wind power, and this is the Danish wind power here. This is the EU average, so we have almost 20% wind power in the grid. Down you have Bulgaria, Italy, France, Austria, Romania, Poland, Croatia. Up here, Ireland, an island system, by the way, where they have very significant shares. Portugal, Germany, Netherlands, Spain, etc. So this expansion of renewables that we see after the invasion of Ukraine is really what helps us reduce the consumption of gas. But it also has its limits. So on average in EU, I would say we're not able to go to the Danish side. We're maybe able to go to the 40 or 45% until we change the demand side. So that's of course an important part of this. I think I'll skip that. This is the primary energy demand in Europe, and there has been some relative successes in this structure. You can see it's falling a little. That's both due to this ammonia not being produced and a few heavy industries not there, but it's actually also due to the 20% wind power. So what happens in the beginning when you put up a wind turbine is that 1 kilowatt hour of wind replaces 2.5 kilowatt hours of coal or natural gas because of the losses in the power plant. So you have a structural efficiency gain. We can also see that we have better houses, so we heat maybe 20-25% more square meters compared to 25 years ago. We use the same amount of heat for that. So buildings are better in Europe than they were in 2000, for example. There are some challenges. The electrification in Europe is going really slow. Heat supply remains really highly based on boilers. We have too little energy efficiency still. There's really a lot we can do. And when you look at this graph, I think it's important to understand that the electricity consumption is a smaller part of this. So what I talked about before, the 20% penetration in electricity sector of wind power, for example, the electricity sector maybe around 25-30% of this overall demand. So it's eating into the existing electricity demand. So what we want to do when we design our system is to eat into all of the other demands in industry, in houses, heating of houses, in the transport sector, etc. We have done that in the Danish case, where if you compare the European continent to Denmark, we are around 20 years ahead from the system design perspective, I would say. And here you can actually see quite a large decrease. There are three reasons for this being constant during this time, actually. So one is the insulation of buildings, the second is the use of district heating, and the third is the upscaling of wind power. And what you see after this period here are actually the effects also of the electrification of transport, but mainly actually also of heating, where you see that the primary energy supply is actually decreasing. I don't know if you know, but in some of the European countries, PV is a really big debate. But it's funny to see on this graph. It's a really big debate in Denmark as well. We had municipal elections, and a lot of people were thrown out of office due to PV. But this is the amount of PV in the overall system. So it's really not that big. It will be bigger, but not 10 times as big, of course. Anyway, so what is started to be done here in Denmark is to redesign the system so that we're integrating this in a smart energy system where we combine the different energy carriers, gas, district heating, and the heating to the electricity sector as well. The goal is we aim for 50% reduction of CO2 emissions from 1990. We achieved that, and in 4 years we aim for a 70% reduction of greenhouse gases. So in 2030, and this is going to happen. It's on track, mainly with known technologies, actually. But it also means that the whole energy sector, more or less, has to be decarbonized. There will still be industry, there will still be transport, there will still be agriculture. But to achieve the 70%, the electricity that you can get from the grid and the district heating and most of the heating system actually needs to be changed. But this can be done, and it's being done. One of the things that's important is to understand the storage. So in this system, which is not dominated solely by PV, the storage becomes very important. And we can see that thermal storage is 100 times cheaper than electricity storage. And we can also see that bigger storages are much cheaper than smaller storages. So the trick is to use bigger storages and thermal storages. And we need hot water in the future, so we might as well produce it and store it as best possible. So this is what we're trying to do. In the old days, you would say that we would have wind power and provide the electricity, and then we would have a thermal storage tank here where we would get through the district heating our hot water, and we would stop the CHP plant. Then over here, when we have low wind, we would run the CHP plant, we would fill the thermal storage, we would still get our supply over here. This is a little outdated because actually we don't need the power plants as much as we did in the past. In the future, we need to have power plants that operate maybe 5 to 15% of the time. We can still use the excess heat from that, but it's not always correlated with when we have the heat demand, and we can't have a heat supply based on it. So we have to change this, and one way to change it is to have a large-scale heat pump in the heating system. So as you know, a heat pump has a good cup of 3 or up to 5 or even higher if you have a good heat source. What you want to do is to have big heat pumps, combine them with thermal storages, and then you're actually able to supply much more of the heat compared to a system where you have so much combined heat and power. So this is the installation in the Danish system of heat pumps and electric boilers. So over here you you can see the electric boilers, and on top are the heat pumps. Electric heating is not a good idea. So these are not operated very much. If the price is 0 or below 0, they will operate these. But these up here, they are the heat pumps. And we will have quite a lot of heat pumps coming up in the coming years. But you can see already now we have the possibility to have a flexible demand combined with thermal storage of more than 2 gigawatts, which is quite a lot. So we can immediately activate 2 gigawatt of demand when we have a large amount of wind power or PV in the system that we need to take. And we use it productively because it's then stored to provide heat at another time. So this is how we want to try and redesign the system. And this is actually happening. So I visited Aalborg last spring, and I was kicking these big metal cans. So these are simple metal cans, 2 layers, very, very simple thermal storage. And they can provide heat for a city of 200,000 people for 1 to 3 days in the wintertime. Not in an average day in the wintertime. And that means you really create quite a lot of flexibility. So this is for 200,000 inhabitants, and they have a heat pump of around 67 megawatts provided by the company Main Energy, which is renamed to something I forgot ever. I can't remember what it's called, but it's actually based on Main Energy. You're not able to buy those heat pumps, so they are manufactured based on engines they put in drilling holes 3 kilometers, 2 kilometers down for oil, which have to operate, and they cannot be maintained, they cannot be fixed. When they're there, they operate. And these heat pumps are done with exactly the same technology, just applied in large-scale heat pumps instead. So this is really an enabling technology. So when you see a thermal storage like that, that is the most important renewable energy integration technology. I think I spent a lot of time, so I'll just skip if I have more time. So what we also want to do is we want to store gas and liquid fuels. So some of you are working with Power to X, and now I talked a little about heating, which we can produce flexibly. We can also produce Power to X fuels flexibly. So if we want to have aviation and shipping in the future, we need to produce eSAF or ammonia or methanol for the ships. Now, instead of storing the coal on the input side or the oil on the input side of the ship, we store the product that needs to go into the ship. So we change the storage from the input to the output side. And this is really also a key enabler to enhance the amount of renewables that we can put in. And as I said in the beginning, the idea is to enable as much of the cheap electricity to come in as possible. So this is really, really important. And I guess you know the electrolysis process. There's been a lot of hype about how fast you can do the deployment of electrolyzers. Maybe we can go into that in the questions, but it will take 10 more years before it's scaled up. I think we in Denmark have now 2 plants on 22 megawatts of electrolysis or something like that, maybe 3. But they need to go to gigawatt size within 10 years, and I'm sure that they can. People thought it would be now they would be gigawatt size. Then those people probably did not understand the upscaling is harder than what you can calculate on the computer. So another important thing when we upscale this and when we want to integrate more renewables is to understand the locations of different elements. So you have the Danish map up there. The green dots represents areas where we have a surplus of electricity. And the yellow, renewable electricity, sorry. The yellow ones represents areas where we have too little renewables. So when you have more than 50% renewable energy, you want to start planning a little differently, because otherwise you end up with a copper plate. And it's really expensive to transport electricity. So if you want to deploy more renewables, they should be placed where you don't have a lot to begin with, so close to existing high demand hubs or new demands that you want to put together with the renewables. And if we don't do that, we will end up with a very, very expensive system, I would say. So this is sort of part of the new exercise. We're talking also about overplanting. So we have direct lines from an offshore hub to an electrolysis plant. It doesn't even go to the market. It's sort of outside the market. So there's a lot of thought going into this. Data centers are placed close to new demands, for example. So we need to have actually a rather good framework to do this kind of planning. We have applied these methods of this smart energy systems integration in several studies. So this is one recent study that our team did called HeatRoadmap Europe, and this is this is sort of based on a redesign of the European energy system. Here you see the current demand, which is around 15 petawatt hours, and this is a future demand, which is around 9 petawatt hours. And what we do here is we do all of the principles that I talked about. What you can electrify, we electrify. If we can do savings, we do savings. If we can do sector integration, we do sector integration. And we apply the cheaper storage options. When we apply the cheaper storage options, the prices on the system level do not increase. They can decrease or stay the same. In this scenario, we calculated also how much wind, offshore wind and PV we need. Maybe we can debate that in the panel tonight. But you see, we actually installed here almost 2,000 gigawatts of onshore wind, which is quite significant. And also we installed 1,600 gigawatts of PV, which is a lot, but which is possible if you think about also the roofs. One key thing that we did here as well was to accept a much larger excess electricity than I thought we should. So normally, in our experience, we would say it's okay, you lose 5 to 8% of your electricity production. But we found, due to the falling prices of onshore wind and especially PV, that from an economic point of view, it makes sense to actually lose up to 15% of the production, because the production is then also in the other hours compared to not only in the summertime, but in the other hours of the year. This has two effects. It has a lowering cost effect, but it also lowers the amount of hours power plants needs to operate, either on natural gas or biogas or some kind of biogenic material. So it's a new sort of design parameter, I would say. What we did in this study was to look specifically at the heating sector, so I'll go through that very quickly. We do heat savings of 43% in the houses over 25 years, and we look at how we supply the heat. The methodology we used for this study was to look at 3 different heat saving levels. We looked at geographical analysis of those future heat demands, so we know the heat demand in Europe down to 100 by 100 meters. We make a comprehensive assessment of waste heat and renewable heat potentials, and make geographical analysis of where they're placed compared to the demands. We look at then 18 different shares between more district heating or lower district heating and more individual heat pumps or less individual heat pumps. We look at different district heating supply mixes, and we do a lot of energy system analysis. And one of the results you can see here, I can see it looks a little strange on this one, but I'll explain it. This is the future heat demand if we have 43% savings. So you can gather that our current heat demand is somewhere up here. This graph here represents the potential of waste heat in Europe from a lot of different sources. So this is deep geothermal, solar thermal, CHP plants, nuclear waste heat, industrial waste heat, high temperature, medium temperature, low temperature, waste to energy plants, wastewater treatment plants, data centers, electrolysis, and some other few sources. When we pile these up, we have more than 3 petawatt hours of waste heat that is not used. We need to use that. If the temperature is right, we use it directly, otherwise we use a heat pump. In these analysis, what we did was combine energy system analysis with geographical analysis. We estimate that we are able to use 650 to 900 terawatt hours per year. This map down here shows the geothermal potential in different layers that we analyzed, for example. The key thing to make this happen is to expand district heating. You can't use waste heat unless you have something to transport the heat with. So we did a lot of analysis on that, and that needs to be expanded, and we suggest it's expanded to more than 50%. I would say from a research point of view, we could probably go a little higher. So this sounds like probably for most Europeans as really a lot, but it's a more pragmatic number than a lot from a calculating point of view. There are particularly high potentials in France, Germany, Netherlands, Spain, and Belgium. This is the percentage of district heating. Here's, for example, Belgium. Here we have Denmark. And here next to us we have Germany. So there are really quite a lot of potentials. Some that have very low potentials is Croatia, partly also Hungary. But all of this has to do with how far are the houses and the heat demands apart from each other, and how close are they. We have maps of this where you can go in and see, okay, we have a high temperature industry in this area. Should we that combined then with what's it called, where the heat demands are. Very quickly, this is the district heating production. This represents large-scale heat pumps, which you saw is being deployed already. So with the district heating system, and we can actually have almost 40% electrification. We have thermal storage. We use waste heat. More than 1/3 of waste heat is used, and we used around 10% renewable sources for heating. On a map, we have, for example, here the high temperature heat, industrial waste heat, and you can say, especially in the Benelux countries and the Ruhr district, you have a high concentration of heat that you can simply use directly into a district heating system. But there are many other places. This is only representing where there's a waste heat, and where there's a heat demand in buildings. So there are actually more than this. They're just not close to the heat demands. So you can go in and I can send you the report. I would just like to mention that when we do this kind of system, we reduce the overall system cost by 2 to 3%, including the expenditures for vehicles. So that's the system level reduction when we have a smart energy approach. Of course, it doesn't sound like a lot, but when you consider it's the whole system, And this is only the heating sector we're changing. It's quite a lot. For the heating sector alone, a redesign means 10 to 20% lower cost. And that will mean that some that have district heating will have much lower cost compared to today. So it really creates a much more resilient system. So if we want to attend to the geopolitical challenges we have, we need to try and harvest some of these very, very important redesign options. Thank you for your attention.
Thank you so much for the very nice and interesting presentation. What we will do next, I'll go ahead with 1 or 2 questions, and then I'll open the mic for everyone here to ask questions to Professor Mathiesen. So first of all, on the geopolitical aspects and natural gas. Natural gas has been seen or proposed as a transition fuel as well. So do you see this natural gas, idea being a delay, idea or delay option for the transition towards renewable, and how much that delay can actually be basically influenced by the geopolitical aspect that you also discussed?
I think in some countries, what was done until the war started is a delay. Mm-hmm. But it's a little like saying, oh, don't you think electrification is a good idea? And then I tell you, no, it's not a good idea unless you do a smart electrification. Mm-hmm. But we don't want to heat our buildings with electric heating, right? Everybody knows that's a bad idea. But we want to try and have an intelligent electrification, maybe with heat pumps or combination of heat pumps and district heating. And the same thing goes for natural gas. It's a really bad idea to reinvest and expand the use of natural gas to heat houses. Mm-hmm. But it's a good idea to have flexible natural gas-based power plants that can support the grid, because there will be hours where we need capacity to support the grid. So I think the term, in my opinion, is too general. Mm-hmm. And people think when you say it's a transition fuel, then we should just use it everywhere we can. That's not true.
It can create lock-in effects also.
It can for some sectors, yeah. There are some sectors we like to be locked into a gas system somehow, which is the power sector. And those very few industries where you may need gas, which is actually, we found out that at least 75% of the European industry can be electrified, probably even more.
Thank you. Follow-up question on the smart system aspects. So I understand, from a European perspective and Danish perspective as well, that heat can actually provide a lot of flexibility in the heating sector. But if we think about the Latin American context, we are in a totally different environment. Even here in Colombia, it's extremely hot. Heat demand might not be as high as it is in Northern Europe. So we might not see as many possibilities to use the heating sector as a flexibility option in some countries. If we think, for instance, even Chile, which is in South Patagonia, there is a second issue, which is density of population is not very high. Basically translating into basically non-existing district heating at this point. So in the Patagonia, we don't have it. In countries like Colombia, Ecuador, Venezuela, probably we won't also have it. So what are the possibilities that you see actually in Latin America from the flexibility point of view, and how integration can actually be implemented in a continent like Latin America?
I think saying Latin America is too big. You can't say anything general like that. So we can look at Colombia, and I know here you also have a heat demand. Maybe it's a short heating season, but you do have a high heat demand parts of the season. And then the question is, do you have the democratic infrastructure to supply that with district heating, or don't you? So that's not a technical or economic thing. That's more an institutional and democratic setups thing, whether you're able to do it or not. And if you're able to do it, then you have to look at how can we supply district heat in that area. If you're not able to do it, then you have to live with that the system will become more expensive in that area. If we're on the coast here, the heat demand is non-existent. You have probably a large cooling demand. And there is a thing called district cooling. but district cooling applies for commercial centers. I would say where we are in this area, the cooling demand density here is by far high enough to create a district cooling system. But this also requires democratic and institutional setups where you are able to unlock that. But if you wanted to do a modeling about it or to explain how much less cost you would have, sort of a key understanding would be high concentration of commercial cooling demands. You have to investigate district cooling. And what you can do is you can halve the electricity demand. So from an OpEx side of view, there's a huge advantage. Of course, then you have to weigh that up against the investments in PV, but you cannot have enough PV on this peninsula. So then you also have to include the investment in the grid and the, you know. So there's a lot of elements there you could take up, and if you're able to do that, you can actually have a cold storage system combined with the district cooling, and you can actually have a hot water supply as well. One of the best systems in the world for that is actually on the Stanford campus in the US. They implemented some of the Danish thinking of what we call fourth generation district heating, where they have, I think, 2 heat storages and 1 cold storage, and then they combine that. So things are actually possible.
One more question before I turn this to the audience. Something that we might also lack in Latin America, if we compare to the European system, is the power sector integration among countries. Many, power sectors in Latin America are isolated. We don't have many, installed transmission system across countries. So we are basically in many areas isolated. So how does this actually play a role in the transition, or do we actually need this, integration maybe from the transmission power sector point of view before going into sector integration, or we can do both in parallel?
So let's say you don't have the institutional setup or the democratic infrastructure to make district heating or district cooling, and probably not either to integrate on a regional scale the electricity grid. Maybe even in a country you'll have problems to combine areas, I would guess. If you have that problem, then you have to go aggressive on something else. And I didn't mention it in my speech here. I don't know if you know there's a levy in Europe on PVs from China. I think it's a bad idea. What I think we should do, we should have 10 years of full throttle on getting as much PV up as possible, then shut down and develop the new technology. And in a country where you don't have institutional setup properly, so you can build large infrastructure projects, I think it's the same. And what I showed on the picture from Cartagena is a piece of democratic technology employed directly to those who do not have the capabilities or the money to make any large-scale infrastructure project. So this is a complete, change of mind, and those in these areas here, also here in Latin America, where it's hard to connect, those utilities that are stuck with coal or stuck with natural gas, they are in big trouble. Big trouble. Within 10 years, you will see a surge like you've never seen before. And what happens is that money flow is disconnected, which means that the power will change.
Thank you. So now I open the question for the audience. Neven, you can start.
By the way, I disagree with your need for democratic institutions for district cooling. Dubai is a beautiful case of one of the biggest systems. But my question is more related to the fact that you spent 1/3 of your lecture on geopolitics. And I agree with you. It's an important part. And we have basically solved techno-economic issues of the transition. It's all about social resistance, political resistance, delaying. But what I see as a positive factor is that we have 200 different sovereign states in the world, and they come at some point under pressure of the context, and technology is ready. What happened in 2020 in Europe, it happened in South Africa and Pakistan in the last few years, because they have very bad supply of electricity and they just moved solar. This is what you can see one by one country. Ethiopia built a big hydropower plant, and they decided they don't want to spend any more millions on importing oil.
Yeah.
So they just banned internal combustion cars.
Yeah.
And now it's flourishing electric cars in Ethiopia, one of the poorest countries in the world. So this is something that will, in my opinion, be a very strong push for the continuation of transition. We are going to see delay in some countries, but very quick change in other countries. What is your take on that?
Well, the reason I spend a little time on this geopolitical issue is that I think we need to expand the picture for those who make the decisions. And I don't think that a lot of the political systems in Europe know exactly how grave a situation we have. And there's this we have a little less focus on climate. Some parties have a lot still, but then there's a little less, and we have a lot of focus on Trump and trade and economic sovereignty. I visited the Commission in when was it? November, I think it was. I went to DG Energy, which is for sort of the ministry or whatever in the Commission, right? And I talked to the civil servants there. There's a normal speak we can have. Then I went to the Commission and Dan Jørgensen's cabinet. He's the Energy and Housing Commissioner. And the speak there was different. It was like Trump walked into the room. They're afraid of talking of things directly. And the first word that is mentioned all the time are cost reductions. So I think as academics, we have an obligation to tap into what the concerns are, to explain how grave they are, and then present what are the real solutions on your hand. One thing that we can see happen in some countries is that they believe nuclear is a fast way out of this. I was so angry when I heard rather respectable politicians in the Danish media, for example, say that, oh, we want to have nuclear in Denmark to get rid of Russian natural gas. Okay, we start over. So so I think it's really important to tap into what's on the agenda. If I made a speech here talking about only climate change, then you lose half of those that actually can make the decisions, or maybe more than that.
Thank you. Any other questions? Please. If you can also introduce yourself.
Should I stand up? No?
Okay.
Okay, so thank you for your presentation. I'm Laura Mesestrada. I'm from Colombia, but I work in Germany. I just wanted to mention about the democratic institutions as well. In Colombia, we do have democratic institutions. I'm not defending this government because no, I think no one can. But I didn't realize the good things we had until this government came. So I think we do have the democratic institutions, but our problem is the corruption. And what you saw in this picture is corruption. They don't get to all the places. And although this government is destroying these institutions or trying to, hopefully next government will strengthen. So I just wanted to somehow defend what we have, maybe from Europe. I work in Europe. We are not seen sometimes as people with institutions, or the belief of our countries is far behind to what we really have. So I just wanted to mention this, and it's very interesting what you say. Thank you.
Any comments?
Yeah, so I mentioned democratic infrastructure and institutional infrastructure. I didn't say that it's not democratic or that they are not existing, but the thing is you need to adapt them. And there's an interplay between what needs to be implemented and the institutions or companies that are there, and the play then with the authorities and the governmental system. And so you were from Germany, or you work in Germany. In the traditional Germany, you will find even in a democratic country like Germany, a very high connection between the coal mines and the CDU and SPD in Germany, where that created a big login to coal in Germany. And actually, the natural gas crisis we have in Europe is the same. So in Germany, the institutions were not for many years strong enough to be able to change this. They have changed now, gradually. So it doesn't only apply for for Latin America, but there is an interplay between the democratic institutions and setup and yeah.
Thank you. Any other questions? Please, over there. You can also introduce yourself.
Hi, I'm Ofélia Araújo from Federal University of Rio de Janeiro. My question is renewables. Brazil has a wrong strategy of investing in renewables, and it has been doing this since the 70s, way before energy transition was an issue. I would like to know your opinion about it, about renewables. Renewable fuels.
Oh, yeah, okay. So I didn't include this in my speak so much, but the modeling, for example, we do for Europe, that I presented the graph of, there are several parameters, but two of the main parameters are the cost, the overall cost that we can see, and the biomass availability. Because you cannot create a system only with PV and wind. You need to balance the system, and there are some elements you're not able to electrify. So in our experience with the research, it's very clear that if we don't electrify and use biofuels, then it will be completely unsustainable. I think around 12, 13 years ago, we did a lot of studies on land use and per kilometer traveled from different pathways, electrification, bioethanol, e-methanol, sorry, different e-fuels. And it's very clear that if we have a biofuel where we have not infused hydrogen together with the carbon molecules, then we don't have a sustainable fuel. If we have something we can electrify, our land use will be much too big. You can see not only in Brazil, but also in the US, they have a high penetration of biofuels, and it really creates a lot of land use that is completely unsustainable. In Europe, we have, in my opinion, built up an industry which will have sunk costs for many years, and I think we have to stop it. We have 10% blending in many places of bioethanol, which is a really bad idea. Either it's produced in Europe or it's imported probably from South America, creating land use change down here. So we need to ban this. We need to move completely away from this. And in my opinion, it's better to use fossil fuels than biofuels, because it locks us in to something that's completely unsustainable. Having said that, I think it's important to understand that now we talked a little about PV. PV wins because of the laws of physics. EV is going to win because of the laws of physics. So it's not a dangerous policy to move away from bioethanol. It's a good policy.
Thank you. We have time for one more question. Natasha, please.
Okay, given the evolving nature of smart energy systems, do you believe that it's time now to introduce newcomers for being labeling as strategic infrastructure? Like, for example, district heating was mentioned, but also heating and cooling storages, digital platforms, and maybe even production capacities for batteries.
Yeah, so as part of the new, if we take the production capacity, there has been a battery initiative in Europe for many years. It failed a little, some of them, but actually there were 9 initiatives, and 2 of them we heard about, which both failed. But there's still quite a lot of battery initiatives in Europe. So, but you ask about also district heating, and I think it is a key infrastructure. If you see, I think it was 2 years ago, you had a blackout from 2-3 nuclear power plants which were not operating for a number of days, combined with a very cold weather in I think it was in Belgium or the Netherlands or something like this. There was a high dependence on electricity, and I think if we want to be robust and resilient, we need to use our resources more efficiently. But also, it's actually more robust if we have several parameters of several energy carriers to work with. The problem when you talk about what is critical from the EU perspective is that heating is regarded as a national matter. So in my opinion, probably we need to enable it through the national states, and they need to realize that this is actually a matter of energy security.
Thank you. Nevin, do you have a follow-up?
Maybe to comment back on biomass and biofuels. While I fully agree with you that European biofuels energy crops are not sustainable, there are slight differences with Brazilian program. The difference number 1 is that photosynthesis efficiency of European biofuels is up to 2%. Brazilian bioethanol is 8%. And it's not fully energy crop, it's co-production. So it's a kind of way, if you have, if the price of sugar is too low, then you move to the production of alcohol. So it's a bit different. It's not as sustainable as using only waste biomass, but it's much more sustainable than a European approach. And another issue which I find important, while I'm not completely against all the biofuels charade in Europe, which didn't make sense from energy point of view, is because we will need a lot of carbon coming from biomass in the future. So you want to sustain some kind of use of biomass for energy purposes, but in the end, we're going to move that towards methanol.
Yeah, I disagree on both of those issues, I would say. So I think any kilowatt hour of biofuel you use also in Brazil is a bad idea. It creates a login for a system that needs to be dismantled. And it actually enables also Brazil to export cheaply to Europe if they have a surplus. So I think it's a bad thing. In Europe, the build-up of SAF production and bioethanol production does not unlock our ability to harvest the CO2. It's a completely different technology that is needed to extract the CO2, such as biogas or gasification or pyrolysis or technologies like that. Completely different supply chain technology strain compared to bioethanol. So I think we need to be rather harsh on those technologies.
Yeah, Isaac, final question, then we're running out of time.
It is to do with the institutional and democratic approach to this. And to introduce the panel in the afternoon, well, late tonight or in 6 o'clock or something like this. little mention about how important this is right now. I mean, we have made so much progress, and institutional progress, very little. Except for RIMA in the UK, I see nothing else being done in an orderly manner, and in academia is not discussing this. So tell me what you think.
In what respect do you mean?
You know, how to go about it. Let me explain then a bit. For Colombians, that we tend to be very much against this transition in the academia, in industry and government. We say, you know, this is a failure, the transition, because of, you see what happened in Chile, what happened in Spain, what happened in the UK, what happened in the US. So this is a disaster. So we shouldn't take it on. So how do you move in terms of convincing that the institutions are in place and there is a roadmap that could be constructed, and the elements for having this as a success, regardless if you have a blackout of one day, that makes, it doesn't matter. But how do you build trust in this process?
I think I understand. So the role for me and for you is very clear. You need to explain exactly what happened and to break the myths. The Spanish case you mentioned, it has sparked so many myths, and it's being used by climate deniers, and also it's been used as a proponent for saying, oh, we should have had more nuclear power, and it has nothing to do with either of those. So the explanation comes out. It shows it's not what they thought, it's something else. But also, you need to then explain how you can solve it, and that it may happen again, but not to the same extent like it did in the past. So I think our role is to be very factual and punctual, to also say what is actually going on, because there's so many myths about what happened. So maybe some of you heard about the offshore wind tenders as well, or the hydrogen hype some of you may heard about. There's so many details that goes missing when you see the headlines in the newspapers. I don't have time to explain all of the elements in why some of these things fail or why they're not going right. But to tell a story that this is a disaster for the green transition is bullshit. There are so many successes, and we cannot let ourselves say it's a disaster just because something goes wrong with one or two technologies or is delayed 4 or 5 years. When you see so much PV, so much electrification, so much wind power, so many changes going around in many other sectors where we have a success, we have to be able to have a debate about those things that go wrong and still tell a story that we are on the right track, instead of focusing on a blackout in Spain, which was a disaster in those moments. But come on, what has the economic situation been in Spain due to that? It has been a big success. If they did not have that PV or that amount of wind they have, they would have been exposed to the world market of natural gas in 2022 and 23 to an amount that you can only imagine, not even imagine. Yeah, so I think we need to speak things up and be factual.
Thank you so much, Brian. So with this, we conclude the morning session. We go for lunch now down the hall, and I want to thank you again, Dr. Mathiesen, for your excellent presentation. So we have lunch now, and see you in the afternoon. Thank you so much.